Hi, I'm sorry for the delay. Welcome to this live stream. In this stream, I'm just going to be studying my notes, and these have been prepared over a period of time for my MEO Class 4 examinations, and I hope you enjoy it. The process has been extremely, the learning curve has been very delayed, and now it's steep, and I'm really enjoying it. So, here goes. I'm happy to share my knowledge and learn more about this beautiful subject as we go along, and hopefully we learn together. I apologize for the setup, and hopefully we'll get this better going forward. Uh, Maybe midstream I'll change my primary camera for notes, as you can see, or let's see how this goes. So I'm just going to guide you through the process. I'm going to be read, reading out the notes for about 10-15 minutes, and then we're going to go ahead to uh, check out a class and maybe answer some difficult questions that have been asked in previous year's orals. And the idea is to be able to think while the survey asks the questions, and the idea is not to rote learn everything. So here goes. So my ship was MV Duncan Island, and the engine type was an 8-cylinder super long stroke, uh, 60 centimeter bore, uh, manual camshaft controlled engine. It's an internal combustion engine. Length overall 178 to 180 meters, beam 25 meters, bore 600 millimeters, stroke 22 to 92 millimeter, which is about 4 times of the bore. Power developed 16,000 kilowatts. Let's begin with the auxiliary engine bearing clearances. The main bearing clearances are taken via a steel wire. So eventually, uh, so the auxiliary engine is a four-stroke diesel engine that we use on board. The one that was on my ship was an 8L28H32 model, and it was a MAN BMW generator. We had 8 cylinders, and let's see how we would take the crankshaft deflections. So for the auxiliary engine, it is not possible for us to take the main bearings by continuously overhauling the engine. We can take the bearings by So the bearing is bottom loaded in uh, auxiliary diesel engine and it's supported at the top. This design is known as an underslug, and the type of casing for the auxiliary engine is a type trestle type framing. Sorry, frame box. As compared to the diesel engine, that is a box type framing. So how do we take the clearance? We take the clearance between uh, the bearing shell and the journal. So the thickness is taken between the bearing shell and the journal. Since since the bearing is bottom loaded, we take the readings at the top shell. In this method, we don't need to overhaul the complete auxiliary engine every time that we have to take the crankshaft deflection. The crankpin bearing has to be taken out by removing the connecting rod, and thickness is measured at 5 points. So we're talking about the labyrinth seal next. So the labyrinth seal is present on the turbocharger compressor and turbine side, both sides, and also between the impeller and the casing as well. In case the labyrinth seal is leaking, then there would be accumulation, there would be interaction between the exhaust gases and they would try to enter the seal bearing housing. Uh, the seal functions with a number of uh, pressure drops which are available through the design feature. In case gases do come in contact with the lube oil, at the turbine side, they would burn and produce a black brown residue. On the compressor side, surging may occur as on the compressor side, the bearing oil, sorry, will be decreased. So the lube oil will be carried away with the compressor fan functioning. What is the starting air compressor? To start the air compressor, we check the oil level in the standby compressor. We open the suction and discharge. We open the cooling water. We crack the suction open and set it to auto mode. We open the suction till it is full open. So in order to start the compressor, we check that the level, check the oil level on the standby compressor. We open the suction and discharge. We open the cooling water. We crack the suction open and set it to auto mode. We open the suction until it's fully open. To stop the compressor, we need to pump down the refrigerant to the condenser. This implies we close the outlet valve of the condenser. Slowly the supply to the compressor will stop. We close the compressor suction and discharge. We close the condenser cooling water valve and we ensure that the crankcase heater is on. So to stop the engine, we pump the refrigerant to the condenser and close the outlet valve. So, so what is superheat? Superheat is the difference between the actual vapor temperature and the saturation temperature. Subcooling is the temperature difference of liquid saturation temperature. Anyway, so that's about the notes, and it's possibly not very helpful at this time to read out my notes. I'd rather do them quietly, and so let's go ahead and jog our brains a little bit. We'll do some question and answer sessions where I just go through some frequently asked questions, and let's see. Okay, let's go for questions from me, Anjan Manodri. Starting. So we're talking about what are the main engine safety devices and protection systems. Okay, so there are various the two-stroke internal combustion engine functions at uh, high pressure and gives out a large power output. So there are various devices and protection systems that we have on the engine. These are related to the various services that we provide to the engine for combustion. So structurally, the engine is protected against stresses via various bearings, such as the thrust bearing, which transfers the propeller thrust to the hull, the the various shaft bearings that are there on the crankshaft to ensure that the integrity of the crank remains. Uh, Various safeties include and trips. We have various temperatures on in the combustion spaces to give us the combustion temperature. It also gives us a scavenge air temperature. We can also find the crankcase temperature. Uh, an indicator cock is given, which has our senses of the engine. The starting the air air control valve. Uh, Controlled air is given to the engine, allow it for stopping when we need it. Low lubrication alarms and trips are present. Jacket water monitoring systems, such as for temperature of the jacket water in and out, the exhaust gas temperatures in and out, are some of the same that are given on the engine. Let's see what the answer says. Okay. The safety devices include the crankcase relief door. So, in the constructionally, in the crankcase, we have a relief door, which is a one-way valve for releasing excess pressure in case of a crankcase explosion. We have this cabin space relief door to ensure that the cabin spaces do not get overpressurized. We have this relief valve. This is very important. Cylinder head relief valve. We have the starting air relief valve to help us in case of a line explosion. We have the oil mist in the We have a flip trap on the airline. We have a rotation direction interlock on the engine, and we have the turning gear interlock. So very important that I assume that it is a broad category question, while it was relevant to only the maneuvering and the uh, starting and stopping. So the various safety devices include constructionally the pressure head, cylinder head relief valve. We have the cabin space relief valve, the crankcase relief valve, or the door. We have the starting air relief valve, starting air flame trap, rotation direction interlock, and the turning gear interlock, and an oil mist detector. So there are four major types of protection systems. The alarm: when the engine parameters deviate, we hear an audible alarm and sound. Slow down. It is the next safety stage where steps are taken are not adequate, therefore engine is slowed down. Third is shutdown. The shutdown safety devices cut off the fuel supply and the engine stops if there is greater fluctuation in the engine parameters. Starting interlock: it won't allow the engine to start off from standoff condition if the engine has not been properly operated or engaged. So there are starting interlocks. They won't allow the engine to turn unless from a standoff condition unless it has not been properly operated. What are the various alarms? Cooling water high temperature alarm, jacket cooling water low pressure alarm, air cooler high temperature alarm, fuel oil high temperature, fuel oil low pressure. Expansion tank level: control air is used for stopping the engine. Thrust bearing high temperature trip, jacket cooling water alarm, high exhaust alarm, oil mist detector alarm and slow down, crankcase relief valve, thrust bearing high alarm. Numbers twice. What are different slowdown situations and devices? So if the lube oil pressure falls to 1.5, these are slowdown situations. Camshaft pressure falls below 2 bar. There is no cooling of the piston. OMD or main bearings is activated. Lube oil temperature is high at 60 degrees Celsius. Piston cooling temperature is high, 75 degrees Celsius. Jacket water temperature at 88 degrees Celsius. Exhaust temperature 450 degrees Celsius. Scavenge air temperature 65 degrees Celsius. Thrust plug temperature 75 degrees Celsius. Devices include lube oil high temperature, jacket water high temperature, OMD, thrust bearings, control, scavenge air high temperature, exhaust gas high temperature. What are different shutdown situations? Lube oil pressure is very low, 1 bar. Camshaft lube oil pressure 1.5. Jacket cooling is above 95 degrees. Low jacket water pressure 0.1 bar. No lube oil, etc. What are various interlocks? Interlocks are given when certain conditions are met, the engine can be started off. Turning gear engaged interlock. If the turning gear is engaged, the system prevents the engine from starting. Running directions interlock. It requires the supply of fuel if the engine's running direction is not in line with the telegraph. Auxiliary blower off interlock. In case of constant pressure turbocharging, auxiliary blower is provided. Starting air distributor in end position. So this prevents the engine from taking place in the shifting. This prevents starting from taking place if the shifting of the distributor has not been complete. Starting air distributor in end position. Alright, so that was all about today's stream. Thank you, and I hope to see you guys again soon. Thank you.